Welcome to Engineering Mechanics tutorial. Today, we are going to discuss about part 2 of chapter 2, Resultant of Force Systems. The topics for this session are example problems in resultant of forces and applications of principle of moments. So, for example problems in resultant forces, we must find T of x, T of y, P of x, P of y, F, and the angle of inclination of F. So in getting T of x and T of y, we must first get the formula. For T of x is equal to T cosine theta. Since the force T is equal to 200 pounds, and an angle of inclination of 60 degrees is located at the second quadrant of the Cartesian plane. Now x is equal to negative and y is equal to positive. So we could get negative 200 cosine 60. So that T of x is equal to negative 100 pounds. So next formula in getting T of y is T of y is equal to T sine theta. So substituting, T of y is equal to 200 sine 60. So we can get a total of T of y is equal to 173.21 pounds. So for solving P of x and P of y, here in the illustration, we can see that the force P, which is equal to 722 pounds, is at the quadrant 1 or first quadrant, which has a right triangle which sides are 2 and 3. So we must get first the hypotenuse of this right triangle. So in getting that, we can substitute 3 and 2 by using Pythagorean theorem. So square root of 3 squared plus 2 squared, which will be equal to 3.61. By simply following this, P of x all over 3, which is equal to P of y all over 2, which is also equal to 722 pounds, equal to the hypotenuse 3.61. By getting P of x over 3 is equal to 722 pounds all over 3.61. P of x is equal to 722 multiplied by 3 all over 3.61. So we could get P of x, which is 600 pounds. So in getting P of y all over 2 equals 722 pounds all over 3.61. P of y is equal to 722 pounds multiplied by 2 all over 3.61. So we can get a total of P of y is equal to 400 pounds. Now for solving for F, so F is located at the fourth quadrant where y is negative and x is positive. So we can see that f of x is equal to 300 pounds and f of y is equal to negative 250 pounds. So going back, we need to get the resultant f. In getting resultant f, f is equal to the square root of f of x squared plus f of y squared. So by simply substituting the given, f is equal to square root of 300 squared plus 250 squared. So we could get a total of resultant F is equal to 390.51 pounds. So in getting the angle of inclination of the force F, we could use this formula. Theta is equal to cotangent F of y all over F of x. So by simply substituting the given, or theta is equal to cotangent 250 pounds all over 300 pounds. So we can get the angle 39.81 degrees. So next, for the resultant of 3 or more concurrent forces problem. So we must find the summation of x, the summation of y, the resultant, and the angle of inclination in this illustration. In solving resultant of 3 or more concurrent forces, we must first consider the positives and the negatives of the forces in x and y. So for the summation of x, the forces that are positive are in the quadrant 1 and quadrant 4. And the negatives are in the quadrant 2 and quadrant 3. So for the summation of y, all the positives are in the quadrant 1 and quadrant 2. And all the negatives are in the quadrant 3 and the quadrant 4. So next step is to solve first the hypotenuse in this quadrant 3 right angle. So by simply substituting it to the Pythagorean theorem, we could get square root of 5 square plus 12 square, which is equal to 13. So for the summation of x, getting all the forces P, N, Q, and P. For the summation of x is equal to negative 500 cosine 45 plus 477 cosine 30 minus 350 multiplied with 12 all over 13 plus 289 sine 30. Why is that this is sine? Because the angle of inclination in the fourth quadrant is directed in the y-axis. If you wanted to make it a cosine, you can make it, but you need to get the opposite side, which is 60 degrees. Going back, summation of x is equal to negative 353.55 plus 413.09 minus 323.08 plus 144.5. So the total for the summation of x is equal to negative 119.04 Newton. In solving for the summation of y is equal to 500 sine 45 plus 477 sine 30 minus 350 times 5 all over 13 minus 289 cosine 30. We could get the summation of y is equal to 353.55 plus 238.5 minus 134.62 minus 250.28, which gives the total of 206.93 Newton. So in getting the total resultant, this is the formula. R is equal to square root of summation of x squared plus summation of y squared. So by simply substituting the answers for the summation of x and summation of y squared, we could get square root of 119.04 squared plus 206.93 squared, which gives us the total of 238.73 Newton. So for solving angle of inclination, the formula is angle of inclination is equal to cotangent summation of y squared all over x squared. By substituting, angle of inclination is equal to cotangent 206.93 all over 119.04. So we could get a total of 60.09 degrees, which is located at the second quadrant. So next is the applications of principle of moments. For passing through the x and y axis and at an angle with the x axis, the formula for the principle of moments is the summation of moments is equal to f of x multiplied with y minus f of y multiplied by x. Take note that the clockwise rotation is positive and the counterclockwise rotation is negative. So this is an example illustration of the applications of principles of moment, where f of x, this is f of x, is equal to the x component of f of y is equal to the y component of f, the x, which is equal to the moment arm of f, and y, where it is equal to moment arm of f of y. So principle of transmissibility states that a force acting on a rigid body at different points along the force line of action will produce the same effect on the body. Meaning to say that this red arrow here force F goes to the point of point A, point B, and point C, it will turn out that they have just the same forces because it is directly connected with the line of action. So the intercepts of the line of action of F with X and Y axis, so this will be the formula in getting the IY and IX. So summation of moments is equal to F of X multiplied with IY. IY is equal to the summation of moments over the F of X. Summation of moments is equal to F of Y multiplied by IX. IX is equal to summation of moments all over F of Y. To get the proportionality, IY over F of Y is equal to IX all over F of X. Take note that the IX is equal to X-intercept and IY is equal to Y-intercept. So this is an example illustration in a force acting on the roof truss. So as you can see, this is the P, force P, this is the distance, and this is the point A. It simply shows the principle of moments in turning and twisting. So in getting the force acting on a roof truss, the formula would be the summation of moments on A is equal to Py multiplied by AB. So an example problem number 201, a force of F passing through C causes a clockwise moment of 16.59 kg/meter about A and clockwise moment of 9.68 kg/meter about B. Determine the force and its x-intercept. So this is the illustration in the problem. So the solution is in moments in A, which is equal to 16.59 kg/meter, and moments in B, which is equal to 9.68 kg/meter. The required to find is the F and the x-intercept. So the solution in finding, first, get the formula. F is equal to the square root of F of X squared plus F of Y squared. So in solving for F of X and F of Y, the summation of moments in A is equal to F of X multiplied by distance, which is 0.61 meter. 16.59 kg/meter is equal to F of X multiplied with 0.61 meter. F of X is equal to 16.59 kg/meter over 0.61 meter. F of X is equal to 27.2 kilograms. So in getting the summation of moments in B, summation of moments in B is equal to F of Y multiplied with the distance 1.52 meters minus F of X multiplied with 0.91 meter. Substituting, 9.68 kg/meter is equal to F of Y multiplied by 1.52 meter minus 27.2 kg multiplied with 0.91 meter. 9.68 kg/meter is equal to F of Y times 1.52 meter minus 24.75 kg/meter. F of Y is equal to 22.65 kg. So F is equal to the square root of 27.2 squared plus 22.65 kg squared. So the total in F is equal to 35.40 kg. So solving for the proportionality, which is equal to IY, y-intercept all over F of Y, which is equal to x-intercept all over F of X. Substituting the given 0.91 meter all over 22.65 65 kg, which is equal to I of x or x-intercept all over 27.2 kg. X-intercept is equal to 0.91 meter multiplied by 27.2 kg all over 22.65 kg. We will get an answer of x-intercept of 1.09 meter. An alternative solution is by using the summation of moments in B, which is equal to f of y times E. 9.68 kg meter equals 22.65 kg times E. So E is equal to 9.68 kg meter all over 22.65 kg, and we will get a total of E, which is 0.43 meter. To get the Ix or x-intercept, 1.52 minus 0.43 to get the total 1.09 meter. So next problem, a roof truss has a wind load of 75 Newton located at the indicated position from the figure shown. Determine the moment of a force about point A. So this is the illustration. This is P, which is equal to 75 Newton, the angle, which is 30 degrees, and the distance with 1.5 meter. So the solution is first resolve force P into the horizontal and vertical components, projecting it to P. P of y is equal to 75 sine 30, which is equal to 37.5 Newton. P of x is equal to 75 cosine 30, which is equal to 64.95 Newton. So this is the illustration. We need to get the moment of A force at point A. So as we can see, Py is equal to 37.5 Newton and Px is equal to 64.95 Newton. And by using principle of transmissibility, we could transfer this Py and Px to the point B as shown in this illustration. We need to get the summation of moments at A, which is equal to Py multiplied with 1.5 meter. Summation of moments in A is equal to 37.5 times 1.5 meter. Summation of moments in total at A is equal to 56.25 Newton meter. I know you are asking why P of x is not included in the moments, because it is as same as in the line, because it is going to the same direction of the point A, which is the x-axis. So automatically there is no certain distance that can apply to the P of x. So the summation of moments of A is equivalent to 56.25 Newton. So that's it. Thank you for watching and listening. I hope to see you in next videos.